Hello, our video today is going to be on dividing polynomials. The way we're going to do our dividing of polynomials is synthetic division. Now we got to be careful because synthetic division does not always work. It is a trick. Synthetic division is only going to work when we divide by a linear factor. If we are dividing by x squared, not going to work. So when I look at this polynomial here, it is this cubic function divided by this linear function. So my divisor is x minus 1. We want to make sure that we're comfortable with what the pieces are and what they mean. X minus 1 is a factor. Remember that comes from x minus 1 equals 0. So when I move it over, x equals a positive 1 is my solution. So which one is a factor, which one is a solution? Those ideas are going to play a big role in what we do the next few days. When I do synthetic division, I take not the factor, but the solution. I'm going to create this little box. So I put a 1 here. I create that shell. So right now what I want you to do is stop writing. I want you to watch first, then I'll erase it and do the whole thing over again. But watch it first, okay? I take the coefficients. So 1, negative 1, negative 2, and 8. I put those here. 1, negative 1, negative 2, 8. I bring down the first. I multiply. So 1 times 1 is 1, and I put it there. Then I add these numbers. Negative 1 plus 1 is 0. Then I start again. 1 times 0 is 0. That goes there. Negative 2 plus 0 is negative 2. And then I multiply. 1 times negative 2 is a negative 2. 8 minus 2 is 6. What we did is we found the new coefficients of my new equation. So if I have x cubed, this is my polynomial, is a cubic function. I'm dividing it by a linear function. So cubic divided by linear, that means I'm down 1 degree. 3 minus 1. This means that this is 1x squared, 0x minus 2, with a remainder of 6. So my equation would be x squared, no x's, I'm not going to write 0x, minus 2. When I take this remainder, I'm going to put the remainder over my divisor of x minus 1. That would be my answer using synthetic division. All right, again, we're going to erase that and start all over. We didn't have to erase that. Here's my factor. Okay. So again, now it's time for you to start writing. We have the solution on the outside. We make our box. It's the coefficients. 1, negative 1, negative 2, 8. 1, negative 1, negative 2, 8. We bring down the first term. Remember, it's multiplication and then addition. 1 times 1 is 1. We add to get 0. Then we start over. 1 times 0 is 0. We add. 1 times negative 2 is a negative 2. We add to get 6. We started with a cubic function. I divided it by a linear function, which means I'm taking away a degree. So I'm ending up with a quadratic. So this is 1x squared, no x's, minus 2 with a remainder of 6. As I write my answer, I'm not going to write 0x, minus 2. I put my remainder over my factor, that divisor, not the solution. We use the solution to do the synthetic division, but we use the divisor when I write the remainder. What that means, when you have a remainder, it means that 1 is not a true x-intercept. It's not going to divide evenly. So we're going to talk about with synthetic division, you're going to often be asked questions like, is this a factor? Is this a solution? If you have no remainder, it is an x-intercept. It is a solution. If it does not divide evenly and you have a remainder, it means it is not a solution. It is not an x-intercept. And I know we talked about that up here as factor and solution. That is according to from where we started. But if I were to graph this, I would see that there is not an x-intercept at 1. All right, moving on. Do this again. So x plus 2 would be that factor, which means x equals a negative 2. This is that solution that I'm checking. That's how I'm going to divide. One thing that we did not talk about in number 1 that we're going to bring up in our second example is with synthetic division, you have to make sure that everything has a placeholder. So I look at my degrees, 3, 2, 1, 0. I'm not missing any terms, so I'm good. Then we proceed as usual. We look at the coefficients. We have a negative 2. We have 1, negative 2, 8. Oh, look, this is exactly the same as the first example. We bring down our 1. We multiply. Negative 2 times 1 is a negative 2. We add to get negative 3. Negative 2 times negative 3 is a positive 6. We add to get 4. Negative 2 times 4 is a negative 8. 8 minus 8 is 0. That means we have no remainder. As we remind ourselves, we started with x cubed. We divided by x to the first power, which means this is representing the coefficient of a 1x squared. We go 1 down 1 degree. So that's 1x squared minus 3x plus 4. There is no remainder. Remember what that means. If there's no remainder, that means x plus 2 is a factor of that polynomial. There is a solution at negative 2. There is an x-intercept. So I have the same two polynomials. The first one, when I did synthetic division and I got a remainder, that meant if I go to the graph, I am not going to find an x-intercept at 1. If I do synthetic division with the second one, the x plus 2, that means I will find an x-intercept at that negative 2. So no remainder means it's a solution. It is a factor. If there's a remainder, it is not a solution. It is not a factor. I can divide anything I want. It just doesn't mean I'm going to divide evenly. Since we talk about what we mentioned in the last example, we always have to check our pieces. X cubed to x to the first. I am missing that x squared term. If you forget to check and you forget that placeholder, everything's going to be wrong. So you always have to double check that first. X minus 2 is the factor. So we're checking to see if x equals 2 is a solution. We're dividing those polynomials. We have 1, 0, 7, negative 5. When that term was missing, I have to have that placeholder. If I don't have that placeholder, we're going to have problems. And then we proceed. We bring down the first term. We multiply. We add. We multiply. We add. We multiply. We add. Remember, we started with a cubed. We divided out 1 degree, so 3 minus 1. This is meaning that I have 1x squared plus 2x plus 11 with a remainder of 17. Since I have a remainder, it is not an x-intercept. It's not a solution. I can still divide it though. It's like a messy number. So when we write this as our final answer, we put the remainder over that divisor. We are going to be using synthetic division to factor polynomials. So we have factoring methods, but we're going to be using them to factor using another way. Right now, I am going to give you a 0. So when I give you a 0, I am telling you this is a factor. This is a solution. So right here, I'm telling you that x equals 4 is a solution. We're going to use that to do synthetic division. So the 4 goes on the outside, we make our box, we double check, 3, 2, 1, 0, yay, we're not missing any pieces. We take down the coefficients, 2, 3, negative 39, negative 20. We bring down, we multiply, we add, we multiply, we add, we multiply. Negative 20 and a positive 20 has no remainder. If I tell you 4 is a solution and you get a remainder, that means you synthetically divided incorrectly. But we didn't. We know we supported our answer. We thought 4 was a solution. Well, actually, we know 4 is a solution. No remainder supports that idea. We had a cubic. We divided out 1 degree, which is why this is going to be a 2x squared plus 11x plus 5. Our job is to factor. So I've got to keep factoring. I have a quadratic. We know all the ways to factor a quadratic. This particular case, we have 3 terms. The leading coefficient is not a 1, which means I got a Batman. 10x squared, bring down the 2x squared, bring down the 5. Remember here, I'm trying to find numbers that multiply and add. Those numbers are 10 and 1. Group the first 2, group the second 2, pull out that GCF, leaving us with x plus 5. When there isn't a GCF, we pull out that 1. We know that we're on the right track because these pieces are the same. Those 2 GCFs come to form the first factor. That repeated piece is the second factor. So we are almost there. We are so close. I want to write my equation in factored form. So I've got my f of x equals, well, we just used Batman, 2x plus 1, x plus 5. I'm not done though. Look, I had a cubic polynomial. Right now, I only have 1, 2 degrees. I'm missing the third. It comes from that given. If I give you a solution at 4, that means that there is a factor at x minus 4, and you have to account for that in factored form. This is a cubic equation, so we need those 3 factors, the 3 degrees of that cubic polynomial. So we're going to be using synthetic division to factor all of these different polynomials. All right, nice job.